Okay, welcome to Unit 3, Lesson 2. This lesson is about the arrangement of the periodic table, and I am on page 124, which is where Lesson 2 picks up. The essential question, how are elements arranged on the periodic table? Well, by the end of this lesson, you should be able to describe the relationship between the arrangement of the elements on the periodic table and the properties of those elements. Okay, so let's get started. Let's go straight to page 126. All right, I'm on page 126. Basically, at one time, it was believed that fire, wind, earth, and water in various combinations made up pretty much everything on Earth. But by the 1860s, scientists considered there to be at least 60 different basic substances or elements. They saw that many of these elements shared certain physical and chemical properties and began to classify them. Okay? Knowing what you know about the properties of matter, try to classify the elements below. Okay, so I wrote this for you. It says your classification or your categories might be classify them as metal versus nonmetal, or classify them as solid versus liquid versus gas, or what have you. Okay? You're looking at various physical and chemical properties. Okay, on page 127, where it says, how are the elements organized? So around this time, what time? The 1860s. So somewhere in the 1860s, a Russian chemist named Dmitry Mendeleev began thinking about how he could organize the elements based on their properties. And to help him decide how to arrange the elements, Mendeleev made a set of element cards. Each card listed the mass of an atom of each element, as well as some of the element's properties. Mendeleev arranged the cards in various ways, looking for a pattern to emerge. When he arranged the element cards in order of increasing atomic mass, the properties of those elements occurred in a periodic or regularly repeating pattern. For this reason, Mendeleev's arrangement of the elements became known as the periodic table, because periodic means something that occurs repeatedly at predictable intervals. It's a regular repeating pattern. Okay, in the early 1900s, British chemist Henry Moseley showed how Mendeleev's periodic table could be rearranged. After determining the numbers of protons in the atoms of these elements, he arranged the elements on the table in order of increasing atomic number, or number of protons. Moseley's new arrangement of the elements corrected some of the flaws that we had seen in Mendeleev's table. Okay, so if you want, just take a look at page 127. Here, let me zoom it in just a second. Okay, so make sure that you write down what the word periodic means. Okay, that something occurs repeatedly at predictable intervals. Make sure that you make a note that Mendeleev's table was arranged by atomic mass. And I've answered number 6 for you. How did Henry Moseley revise Mendeleev's periodic table? Moseley arranged the table by atomic number, which reordered the elements in a few places, which ultimately fixed some of the problems that they were seeing. Okay, on page 128 and 129 is a layout of the periodic table. And I want to draw your attention to a couple of things about this table. First of all, the table in your textbook just so happens to use the colors blue, purple, and sort of an orangey red. Not all tables use the same color scheme. Some of them subdivide and are even more colorful because certain columns are called certain things and things like that. But at a minimum, we hope to point out metals, nonmetals, and metalloids. In this particular table that you're given in the textbook, your metals are blue, your nonmetals are purple, and your metalloids are kind of an orange color. Also, if you look where you've got the key right there kind of in the middle, chemical symbol, if it's written in black, that means that substance is solid at room temperature. If it's red, it's liquid at room temperature. And if it's written in white, it is a gas at room temperature. Okay? Now, the periodic table is really kind of an important layout for you to understand. And it's a tool that you'll have access to. So it's not that you need to memorize the whole thing. But when you go down a vertical column, okay, so on the left with hydrogen at the top, that is column 1. Next to it is column 2, okay. Then you have some shorter columns, and then you have some taller columns again with group 13, 14, etc. Okay. Horizontally across the table, you have rows or periods. Okay. Period 1, the only 2 elements in period 1 are hydrogen and helium. Period 2, there are 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3, there are also 8 elements. And then periods 4, 5, 6, and 7 have more elements in them. Okay. Now, there's nothing magical about the 2 rows that are always stuck down there below the table. If you notice, there's a little bubble around something down towards the bottom where it says page 128. The little bubble, it says these elements are placed below the table to allow the table to be narrower, because they should fit right there between lanthanum, hafnium, actinium, and rutherfordium, and it would make the table so wide that it's hard to fit on a page or 2 pages. So that's really the only reason why they did that. Okay, but it's really important for you to remember that a row is horizontal, goes across the table, and it's also known as a period, and that a column is vertical, and columns are also groups or families. Okay, so we're going to get into groups, families, and rows and periods in just a second. Okay, we have some familiarity with the content of these 2 pages just simply because we've done some reviewing and we've already talked a little bit about atoms. What information is contained in each square on the periodic table? Well, periodic tables, like I said, not all of them are exactly alike or formatted exactly alike, but usually there's at least 4 pieces of information in each square. Okay, the atomic number, which is the number of protons in the nucleus of the atom of that element. There's usually the chemical symbol, which is an abbreviation for the element's name. The first letter is always capitalized, and if there's 2 letters, then the second letter is always lowercase. So capitalized and then lowercase. Typically, the chemical name is also given, and some of the ones, that you see might be named after people. They might be named from like a Latin name or a name from another language. So sometimes they're not familiar to you just because they come from somewhere else. Okay. The 4th piece of information that's typically in each box is the average atomic mass. All atoms of a given element contain the same number of protons. That's what makes aluminum aluminum. All aluminum atoms have 13 protons, but not all aluminum atoms have 14 neutrons. That's the most common, but there are a few aluminum atoms, a small percentage of aluminum atoms that only have, say, 13 neutrons. And so the average atomic mass is, if you could take all of the aluminum atoms and find the mass of all of the individual aluminum atoms, most of them are going to have a mass of 27 because 13 protons and 14 neutrons. But some are going to have 13 protons and only 13 neutrons. So when you average it out, it comes out to 26.98. That's where that average atomic mass comes from. Okay? All right, on page 131, how are the elements arranged on the periodic table? Okay? Well, first of all, elements on the periodic table can be classified into 3 major categories: metals, nonmetals, and metalloids. And we reviewed those a few weeks ago. The zigzag line or the stair-step line on the periodic table can help you kind of identify where these 3 classes of elements are located. Except for hydrogen, the elements to the left of the zigzag line are metals. Okay? You'll learn why hydrogen is placed over there, probably in this lesson later. Metals are elements that are shiny, conduct heat and electricity well, they're malleable, they're ductile. Okay, most metals are solid at room temperature. Like I said, many are malleable, some metals are ductile, meaning they can be drawn into wires. Okay. Elements to the right of the zigzag line are nonmetals. Nonmetals are poor conductors of heat and electricity. They're usually dull, meaning they're not shiny, and they're brittle, meaning if you smashed them with a hammer, they would smash into pieces. Metalloids are the elements that pretty much sit right along the zigzag line on the periodic table, and metalloids, remember, just have some characteristics of metals and some characteristics of nonmetals. Okay. Again, your particular periodic table for your textbook shows you metals in kind of a light blue, nonmetals in purple, and your metalloids are kind of an orange color. But, it depends on who's making the table. They may do black, white, and green. Who knows? Okay. So just don't get stuck on the colors. Just make sure that you read the key so that you know what the colors mean.